Okay, so just a little bit more about angle of depression and angle of elevation. So, say you have something and you're flying in the air and you're looking down at a flower or something. Anyway, this is the angle of depression. Normally, your book does not have it labeled that way. And I'm not really sure why. If you look on the internet, you'll see all of them will say it the way that I showed you in the other video. But what I want to point out is that angle there, call it A, is equal to that angle there, A. So that's a geometry principle. Those are equal. This is some other angle. Now, A and B are complementary, but for some reason your book is calling this part the angle of depression, but that's not the definition of angle of depression. So I'm not really sure why. The good news is I looked at the homework in the book and it looks like they're all described by angle of elevation. So I don't know that it'll come up, but anyway, normally this angle here is what we call the angle of depression. Okay. Let's go to this problem then. To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between a line of sight to the top of the tree and the ground. Find the height of the tree. Okay, so sometimes they give you a picture. Sometimes you have to draw your own picture. If I was going to draw this picture, I was going to make a palm tree. But anyway, I'm being in 29 palms. So here's a person. And she walks 30 feet. And then she looks up to the top of the tree, okay? Now, we have to assume that her eyes are like she's laying down, looking up at the tree, that her height isn't a factor in this case. Okay, so when the person walks to the point 30 feet from the base of the tree, she measures an angle of 57 degrees between a line of sight to the top of the tree and the ground. So this is 57 degrees. Okay, now we actually have a tool on campus. It's a little tool that we can go and we can cite the degree measurement for the angle of elevation. I can't remember what that tool's called, but if we were on campus, I could take you out and we could find the height of the building or a flagpole, something like that, on campus. It's kind of fun to do. But anyway, we're not on campus, so we just have to simulate it here in this diagram. Okay, so now we know that measure. We know this 30 feet is how far away she walked from the tree. We don't know the hypotenuse, but we don't need to know that. We want to know the height of the tree. So I'm going to call this X for the height of the tree. Now, when you're trying to decide what trig function to use, look at what you know and what you're trying to find. I'm trying to find the opposite side, right? Because I only know this angle 57 degrees. You could find this angle because it has to be complementary, but we'll go with the angle that we have. And we know the adjacent side. We don't know anything about the hypotenuse, but we don't have to know all three. We just have to know, in this case, the angle on one side to find the other side. And so we want to use the relationship that has opposite and adjacent, and that's going to be tangent. So the tangent of my angle, 57 degrees, is going to equal the opposite, x, over adjacent, which is 30. Now to solve for x, I just use a little algebra. 30 times tangent 57 degrees. That will equal x. So then I want to get my calculator out, turn my calculator on. I need to make sure I'm in degrees, okay? So I want to put my calculator in degree mode. And then I got it in degree mode. Okay, so then I go 30 times tangent of 57. And what do I get? I get x is about 46.2 feet. Okay? All right, so that's how tall the tree is. So you don't have to climb up to the top of the tree and try to drop a tape measure down. You can use the trigonometry to figure out how tall that tree is.